The Finley Holiday slide cassette program that you are about to see and hear is the first of its kind ever made available to the public. And it is a new high in audio-visual entertainment for people of all ages. It's very simple to use. Please follow these instructions. First, place your 40 slides in the projector and move to slide 1. Then, each time that you hear the tone, advance the slide. It's as simple as that. So now, sit back and let's enjoy the show.
In ancient times long gone by, scientists believed Saturn to be the most distant planet from the Sun. It was not until Sir William Herschel discovered Uranus in 1781 that anyone knew of the existence of planets beyond Saturn. Actually, Saturn is the 6th planet from the Sun, and it is unique in the solar system because it is the only planet lighter than water. It has a density of 0.7 grams per cubic centimeter, compared with water's weight of 1 gram per cc. Saturn's most distinctive feature is, of course, its rings, and the image on your screen represents the finest view available of them from Earth-bound telescopic systems. Voyager first began its encounter with Saturn in late August 1980. Coming from its monumentally successful encounter with Jupiter, the spacecraft first began transmitting photographs of the great ringed planet from as far away as 66 million miles. Even from that distance, as seen here, the quality and detail are far superior to any picture shot by man on Earth's surface. Readily visible are 3 of the planet's satellites, a series of dark and light clouds appearing through high-altitude atmospheric haze, the shadow of the rings on the planet's disk, and considerable structural detail in the ring. Much closer now, Voyager 1 took this photograph when the spacecraft was only 21.1 million miles from the planet. Dione, one of Saturn's inner satellites, appears as 3 color spots just below the planet's south pole. An abundance of previously unseen detail is apparent in the rings. For example, a gap in the dark innermost ring, called the C ring or creep ring, is clearly seen. Material is seen within the wide Cassini division, separating the middle B ring from the outermost ring, the A ring. The Encke division is shown near the outer edge of the A ring. This computer composite of 4 Voyager photos contains a wealth of new information on the rings of Saturn. Voyager 1 took the pictures while 25 million miles from the planet. Although the colors are false due to computer enhancement, color variations are real. Satellite Mimas is at the bottom edge of the photo. The bright spot to the right of your screen is just an artifact of processing. Portions of 4 of Saturn's rings can be seen here. The smaller arc-shaped feature in the lower right is part of the F ring discovered by Pioneer 11. The black dots, seen in this image and throughout the program, are Rhea marks, which are artifacts of the Voyager camera system. 2 small satellites of Saturn discovered by Voyager 1 are seen in this photograph taken by the spacecraft at a distance of 15.5 million miles from Saturn. The smaller, innermost of the 2 has a radius of about 155 miles and is seen near the bottom edge of the A ring to the left of your screen. It travels an orbit between the A ring and the F ring. The second satellite, seen just outside the F ring at the top of your screen, is about 186 miles in radius. This image of Saturn was color enhanced to increase the visibility of large, bright features in Saturn's north temperate belt. It is believed that these spots might closely resemble gigantic convective storms, similar to but much larger than thunderstorms in Earth's atmosphere. The largest violet-colored cloud belt is Saturn's north equatorial belt. The distinct color difference between this and other belts and zones may be due to a thicker haze layer covering the northern portion of the belt. Dark spoke-like features in Saturn's rings are seen revolving around the planet with the ring's orbital motion in these 6 photographs taken by the Voyager spacecraft. The images were taken in sequence, from upper left of your screen to lower right, approximately every 15 minutes at a distance of about 14.9 million miles. These spokes are not permanent. They appear for several hours and then disappear. They do not make a complete rotation of the planet as individual spokes. However, they are continually present as a feature. Saturn and two of its moons, Tethys above and Dione, were photographed by Voyager 1 from 8 million miles. The shadows of Saturn's 3 bright rings and Tethys are cast onto the cloud tops. The limb of the planet can be easily seen through the 2,170-mile wide Cassini division, which separates the A ring and the B ring. The view through the much narrower Encke division near the outer edge of the A ring is much less clear. This photograph of Saturn's rings, taken by Voyager 1 at a range of 8.19 million miles, shows complex structure within the Cassini division never seen before. Seen within the division are 4 bright ringlets, separated by darker components and an outer ringlet of medium brightness. All of these internal features are bounded by an inner and outer dark division. Such structure within the Cassini division suggests that some mechanism, other than the interaction between Saturn's satellites and the orbit of the ring particles, must be responsible for the detailed structure of Saturn's rings. This enhanced color image of the northern hemisphere of Saturn, taken by Voyager 1 at a range of 5.5 million miles, shows a variety of features in Saturn's clouds. Small-scale convective cloud features are visible in the brown belt. An isolated convective cloud with a dark ring is seen in the light brown zone, and a longitudinal wave is visible in the light blue region. The smallest features visible in this photograph are about 109 miles across. Saturn's southern hemisphere is shown in this false color image taken by Voyager 1 from a distance of 4.9 million miles. The color contrasts are an indication of the divisions between belts and zones in this region. The shadow of the satellite Dione is seen as a dark circle on the face of the planet. A large red cloud feature, 7,456 miles in length, is evident in the south polar latitudes and has been seen continuously by Voyager since August 1980. A computer assembled this 2-image mosaic of Saturn's rings taken by Voyager 1 at a range of 5 million miles. It shows approximately 95 individual concentric features in the rings. The extraordinarily complex structure of the rings is easily seen across the entire span of the ring system. The 14th satellite of Saturn, discovered by Voyager 1, is seen at the upper left of your screen, just inside the narrow F ring. This F ring is less than 93 miles wide. The unique red oval cloud feature, located at 55 degrees south latitude, is shown in this false color image of Saturn's southern hemisphere. The photograph was taken by the spacecraft at a distance of about 5 1/3 million miles. The difference in color between the red oval and the surrounding bluish clouds indicates that material within the oval contains a substance that absorbs more blue and violet light than the bluish clouds. 2 brown ovals at the right of your screen, some 6,000 miles across, were found at approximately 40 degrees and 60 degrees latitude in Saturn's northern hemisphere. The photo was taken from a range of 4,600,000 miles. The polar oval, upper right, has a structure similar to the Saturn red spot located in the southern polar latitudes. Saturn is the second largest planet in our solar system. It has a volume 815 times that of Earth, but a mass only 95.2 times greater. Like its giant neighbor Jupiter, Saturn's extremely rapid rotation has caused the planet to be flattened at its poles. The clouds covering Saturn's satellite Titan are seen in their true colors in this image taken by Voyager at a distance of 2.8 million miles. Titan's southern hemisphere appears as the lighter region with a well-defined boundary between the clouds around the satellite's equator. Titan's surface is believed to be shrouded by aerosols rather than the convected clouds found in the atmospheres of Jupiter and Saturn. Titan is one of the largest satellites in the solar system. Its size approximates the planet Mercury, and it is the only satellite to have retained a substantial atmosphere. Saturn and its satellites Tethys, outer left, Enceladus, inner left, and Mimas, to the right of the rings, are seen in this mosaic of images taken by Voyager 1 from a distance of 11 million miles. Features larger than 220 miles are visible. The projected width of the rings at the center of the disk is 6,000 miles. Saturn was thought to be the only planet encircled by rings until the discovery of Uranus rings in 1977 and Jupiter's in 1979. The heavily cratered surface of Tethys was photographed from a distance of 750,000 miles by Voyager 1. This face of Tethys looks toward Saturn and shows a large valley about 500 miles long and 40 miles wide. The craters are probably the result of impacts, and the valley appears to be a large fracture of unknown origin. The diameter of Tethys is about 600 miles, or slightly less than 1/3 the size of our moon. A color portrait of Saturn's moon Rhea was reconstructed from 3 Voyager 1 images. Range from the spacecraft to the moon was about 1 million miles, giving a resolution of about 20 miles on Rhea's surface. The color has been exaggerated somewhat to bring out subtle color differences between the brighter streaks and darker background. The photo shows many wispy light markings on Rhea's surface, which are neither identical to simple ray crater markings nor the grooved terrain on Ganymede in the Jovian system. Here we see a view of Saturn's clouds extending from 40 degrees to 60 degrees north latitude. Visible is a ribbon-like wave structure in the south with small convective features marking a westward jet in the north. Like the 3 other gas giants, Jupiter, Neptune, and Uranus, Saturn has no solid surface, but is a huge multi-layered globe of gas with a small core of iron and rocky material. Saturn's F, or outermost ring, was photographed from the unilluminated face of the rings by Voyager 1 at a range of 470,000 miles. 2 narrow, braided, bright rings that trace distinct orbits are evident. Visible also is a broader, very diffuse component about 20 miles in width. Note the knots, which probably are local clumps of ring material, but may be mini-moons. This enhanced Voyager 1 image was taken when the spacecraft was 2 million miles from the planet. The smallest features seen are 36 miles. Enhancement has brought out contrast of features in the north polar region of Saturn. The chevron-type pattern of white features in this upper portion of the image reflects the local cloud motion. Many large impact craters are seen in this view of the satellite Dione, taken by Voyager 1 from a distance of 149,000 miles. Bright, radiating patterns probably represent debris rays thrown out of impact craters. Other bright areas may be topographic ridges and valleys. Also visible are irregular valleys that represent old fault troughs degraded by impacts. Multiple impact craters are seen on the ancient surface of Rhea in this picture taken by Voyager 1 at a range of 45,000 miles. The craters closely resemble those on Mercury and the Earth's moon. Many of the craters have central peaks formed by rebound of the floor during the explosive formation of the crater. These Voyager 1 images of Saturn's 11th moon, a trailing co-orbital satellite, were taken from a range of 110,000 miles and show the south polar region of the body. The pockmarked moon is approximately 83 by 43 miles. Comparison of the 2 images, taken 13 minutes apart, reveal a narrow shadow moving across its face. This is probably cast by a small narrow ring of Saturn a few thousand kilometers away from the satellite. A large circular feature about 120 miles across with a dark spot in its center is visible in this photograph of the satellite Iapetus. The moon's leading hemisphere is to the left, and the trailing hemisphere, 4 to 5 times brighter, is to the right. The large circular feature is probably a large impact structure outlined by dark material, possibly thrown out by the impact. Titan's thick haze layer is shown in this Voyager 1 image taken from 270,000 miles away. Voyager images of Saturn's largest moon show Titan completely enveloped by haze that merges with a darker hood or cloud layer over the North Pole. The spacecraft's instruments found that the moon has a substantial atmosphere, far denser than that of Mars and possibly denser than Earth's. 8 hours after its closest approach to Saturn on November 12, 1980, Voyager 1 took this picture of the planet's ring system. Major features of the rings are clearly seen. The photo was taken from an angle of approximately 30 degrees above the ring plane. The unique lighting in this view brings out many hundreds of light and dark ringlets that make up this very thin, phonograph record-like ring system. Many impact craters, the result of the collision of cosmic debris, are shown in this Voyager 1 color mosaic of the moon Dione. The largest crater is less than 62 miles in diameter and shows a well-developed central peak. Bright rays represent material ejected from other impact craters. Sinuous valleys, probably formed by faults, break the moon's icy crust. Dione is seen here in transit 234,000 miles above the clouds of Saturn in this Voyager 1 photo. The difference in character between the trailing hemisphere on the moon's left side and its leading hemisphere is quite apparent. The trailing hemisphere contains relatively dark material crisscrossed by wispy light streaks. The leading hemisphere shows a relatively uniform surface with many impact craters. The cause of the difference is a subject of continuing study by the Voyager imaging team. Low-level contrast between features in Saturn's cloud deck is shown in this Voyager 1 composite photograph taken at a distance of 1,087,000 miles. The small black shadow of Dione is seen near the bottom of your screen. Wind speeds in this latitudinal area are as high as 90 miles per hour, so distances between features increase rapidly. The surface of the satellite Mimas is shown to be heavily cratered, a record of the bombardment that occurred throughout the solar system in its early history some 4 billion years ago. This Voyager 1 photo shows craters as small as 1 mile across. Craters stand shoulder to shoulder on the surface of Saturn's satellite Rhea, seen in this Voyager 1 mosaic of the north polar region of that moon. Rhea is 1,490 miles in diameter and is the most heavily cratered of the moons of Saturn. The largest crater, made by the impact of cosmic debris, is about 185 miles in diameter. Multiple ridges and grooves, visible near the shadow edge, resemble those seen on Earth's moon and Mercury. This computer-enhanced image of Saturn shows the rings and their shadows on the lighted crescent of the planet. The bright limb of Saturn is clearly visible through the rings. This image was enhanced to bring out detail in the rings, causing the illuminated crescent of the planet to be overexposed. The inner region of the rings scatters light in a way that causes it to look bluer than the outer rings. Layers of haze covering Titan are seen in this image taken by Voyager 1 at a range of only 13,700 miles. The colors are enhanced and are used to show details of the haze that shrouds Titan. The underside of Saturn's rings is shown in this photograph taken by Voyager 1 about 10 hours before its closest approach to the planet. This view of the rings is dramatically different than earlier ones of the ring's sunlit face. For example, the normally dark Cassini division now shows as the brightest feature in the rings. Here is another view of Saturn's ring showing the reversal of brightness of the major features when seen from the unilluminated side. This photo was taken on the day of Voyager 1's closest encounter with the planet from a distance of 444,000 miles. The C ring and material in the Cassini division are bright, while the B ring is dark. Voyager 1 took this high-resolution color image of Rhea from a range of 79,500 miles. The area shown is one of the most heavily cratered on the satellite and indicates an ancient surface dating back to the period immediately following the formation of the planets about 4.5 billion years ago. The photograph shows surface features about 1.5 miles in diameter, similar to a view of Earth's moon through a telescope. The cratered surface of Mimas is seen in this image taken by Voyager 1 from a range of 264,000 miles. Impact craters made by the infall of cosmic debris are shown. The largest is more than 62 miles in diameter and displays a prominent central peak. The smaller craters are abundant and indicate an ancient age for Mimas' surface. Voyager 1 looked back at Saturn 4 days after the spacecraft flew past the planet to observe the appearance of Saturn and its rings from this unique perspective. Taken from a distance of 3.3 billion miles, the planet's shadow falls upon the rings, and the bright Saturn crescent is seen through all but the densest portion of the rings. This montage of images of the Saturnian system, taken by Voyager 1 during its Saturn encounter in November 1980, shows Dione in the forefront, Saturn rising behind, Tethys and Mimas fading in the distance to the right of your screen, Enceladus and Rhea off Saturn's rings to the left, and Titan in its distant orbit at the top. Voyager 1 is on a trajectory taking this spacecraft out of the elliptic plane, away from the Sun, and by about 1990, out of the solar system. Voyager 2 is targeted to encounter Uranus in 1986 and possibly Neptune in 1989. To the men and women of NASA and the Jet Propulsion Laboratory in Pasadena, California, we give our profound thanks for a monumental task perfectly executed, bringing to all mankind a knowledge of space frontiers undreamed of by those scientists of old who first put their eyes to a telescopic lens. Your bi-media program is now complete. Please rewind this tape and you will be ready to enjoy it again at your next showing.